What is up, mathletes? So today we're going to dive into these similar triangles. All right, so let's take a look, because this idea of similar triangles, similar shapes, you're going to see it throughout your math classes. It's going to pop up here and there, but it's something we use so often. All right, so here's the idea. So let's say they tell us that these triangles here are similar. Well, notice what we're going to be able to do with this idea is we're going to be able to find missing lengths, right? That's one of the things we could do here. So the way we're going to set this up is I'm going to set this up as proportions, okay? Proportions of the corresponding sides. What are you talking about, Dr. Math? So I'm going to say side DF here. So maybe I'll do a little color coding. So side DF here is going to correspond to side CA here, or AC, since I call it DF. But again, I'm not going to be nitpicking. So I'll say that corresponds with side AC. All right. And we're going to set that proportion equal to the proportion of side FE. Let's color code that for you. FE right here. We're going to say that side corresponds with side CB, which is right here. CB. CB. And my goodness, I didn't even see what happened over here as I was drawing this. I got a whole bunch of scribbling going on. Let me fix that. I think my finger got in the way as I was moving things around. All right, so here we have it. We have DF over AC, and then that equals FE over CB, right? So we're going to set this up as a proportion. That's what we do with these similar triangles, is you have to find out, which sides correspond to one another. And once you know that, then we set the ratio up, the proportion up as follows. All right, so let's go ahead and fill in the blanks. So DF here, we know that side is 8, so let's fill that in. And AC, right, the length of AC, that side is 12. So divided by 12, and it equals FE, and that side is 6, divided by CB. And notice CB, that's one of the sides that we're looking for that we don't know. So we'll call that X. All right, and so now that you have one ratio, one fraction equaling another fraction, then we're allowed to cross multiply here to solve this, right? So we could go ahead and multiply 8 times X and set that equal to, and we'll cross multiply again, and we get 72. And we're solving for this missing side here, right? We're solving for the side CB. So now we just divide both sides by 8, divide by 8, divide by 8. So X here, which is the length of side CB, equals 9. So again, the key when you're using this idea of similar triangles is make sure you identify which sides correspond, right? And so what's the beauty of all this too is some of you might be asking, hey, does it matter if I put the 8 over the 12 or the 12 over the 8? No, because we're doing this cross multiplication, we're setting these up as proportions, it doesn't matter as long as you're consistent, right? So if you're using this triangle to give you your numerator, then this 6, notice I had to have it also in the numerator. If this 8 were in the denominator, then this 6 would also be in the denominator. So you just got to be consistent there. All right, so hopefully that helps. Let's do another example. Follow me. All right, so here's another problem that mathletes all over the world get stuck on. All right, so it's kind of when you have this triangle inside of a triangle situation. And what we're going to say here is that these two lines right here are parallel. All right, that's going to help us out. All righty, so let's dive in here. So what I like to do is think of this as two separate triangles here. So one of your triangles is going to give you like this mini triangle, right? So if I were to maybe, let's see if I could cut this out here so I could get another triangle. So one of my triangles is like this mini triangle with sides 3, 6, and who knows, right? Then we're gonna see which sides correspond to this bigger triangle. And notice we know that this side of 3 corresponds to this side of 5, but this side of 6 corresponds to this is where we got to be careful. Because notice this length from here to here is 6, but the length from here to here is x. So we want to make sure we add those two lengths. All right, so let's go ahead and let's do the setup here. So I'm going to say 5 corresponds to 3. And here is where we got to be careful, because now I'm going to use this length right here, which is not 6, it's not x, but it's x plus 6. So x plus 6 corresponds to this length over here of 6. All right, and the setup is always going to be key when you're using this idea of similar triangles. And now we could simply just cross multiply and solve for x. All right, so let's go ahead and do that. So we're going to cross multiply these two, and you're going to get 3 times x plus 6, right? And then we'll cross multiply the other side and we'll get 30. And there's so many different ways, right? We could distribute that 3. I think that's what most people tend to do. But again, we like to be creative here in Dr. Math Studios and not follow the crowd. So I'm going to go ahead and do something different. I'm just going to divide 3, because again, as long as you're using correct mathematical properties, it doesn't matter what you do, as long as what you do is legit. So again, we're just doing something different here. So those 3's cancel. So you're left with x plus 6 equaling 10. And this next part is huge, because if you haven't done this yet, then you'll probably get no credit. So make sure you smash that like button and subscribe. All right, last step, we subtract 4 from both sides. Subtract 4 from both sides. Here 4, there 4, everywhere 4, 4, and we get x equals 6. So there you have it, folks. Now we found that missing side. All right, let's do one more. All right, so let's check out this problem, because let me give you an insight on the big mistake people make here. All right, so here we have similar triangles, and we're gonna say that this line right here, say it's given, and these two lines are parallel. All right, so because they're parallel, what I want you to do is just focus on those two lines that are parallel, and then you have this transversal. And what we know, right, from our alternate interior angles, that they're going to be the same. So what that's going to help us do is match up our corresponding sides. All right, so what we know now is that this side over here of x plus 5, that's an easy one. The x plus 5, that's going to correspond with this x, right? So that one's given. We know that one. The piece that confuses people is, let me go ahead and use that 10 right there, right? So this 10, since that's what's given, and we know that's going in our numerator. And the piece that people get confused with is, how do I know if to use the 3 or the 4? And so what I say is, label that triangle there. So we know by our alternate interior angles that this angle right here is going to be equal to this angle right here. Again, because these two, right, these two lines right here, these are parallel, and there's my transversal. So I have alternate interior angles, so these two angles right here are the same. All right, so what that means is their opposing sides here are going to correspond. So this 4 is going to correspond with this 10. So the one we're going to use down here is 4, not the 3. All right, so now we have our setup, and now we could go ahead and solve, which is the easy part, because now we know we could cross multiply. So let's just cross multiply, and we get 4 times x plus 5, and then we'll cross multiply over here again, and then you'll get 10x. And so let's just go ahead and solve this, and we are done. So distribute that 4. I would divide both sides by 4, but then it would leave me with a fraction that I don't want to see, so I'm not going to do that. So I actually distributed in this case, right? Could I have done the other way? Absolutely. I would just be left with a fraction, and a lot of people, they hate on fractions, right? Don't be a fraction hater. So all we're doing is solving for x, which I'm sure you have mastered at this point. And then we're going to go ahead and divide by 6. divide by 6. So x equals, let's leave it as a fraction. We'll divide top and bottom by 2. So we're left with 10 over 3 as our value of x, right? And again, always make sure you read the question. This was just a generic question. So there's our value of x. If they wanted you to find this length over here, then we would just go ahead and take our 10/3 and plug it in for x. But again, hopefully this gives you a great understanding of how to use this idea of similar triangles to solve for these missing sides, because you will be doing this a lot. All right, mathletes. So hopefully you enjoyed that. Make sure you smash that like button, subscribe, and we'll see you guys in the next video. Peace.